Let's take a quick look at the first and second laws of thermodynamics. These are the big ones. These laws are immutable and there are no exceptions. In other words, you can take them to the bank. The first law of thermodynamics. You actually know what that is. You just may not know the definition of it. But in light of what we've been doing, it's been buried in there. Let me give you 3 ways that the law of thermodynamics is worded, and then let's talk about it in light of how we've been using the first law. Sometimes it's expressed energy can be neither created nor destroyed in a chemical reaction. That's pretty good. What this means is the heat that's lost somewhere has got to be gained somewhere else. But nothing's created or destroyed, it's just shifted around. Another way it's worded is, more generally, the sum total of matter and energy in the universe is constant. Again, the energy in the universe can shift from one place to another, from system to surroundings, or the other way. It can move all around, but at the end of the day, it's constant. Nothing's being created nor destroyed. And mathematically, we can put that delta G for the universe is 0. So, let's have a look at that schematically. Yes, very familiar diagram. Delta G for the universe is constant. Delta G for the system can change, but the surroundings has to change just as much. So what this essentially means is I can shift heat all around, but no matter what I do, the amount of heat that's lost from my system has to be the same amount that's gained in the surroundings, and vice versa. And we give those processes, those energy shifts, names, but nonetheless, when you sum them all up, they have to equal 0, because this box, our universe, is only so big. Now on to the second law. This is basically the law of entropy. The entropy of the universe is always increasing. In other words, things are always getting spread out. They're getting dispersed. Energy's getting less usable. Things are getting more random. In short, the universe is running down. And given enough time, the millions and billions and trillions of years it might take, barring any supernatural intervention, all of the energy is going to become less and less usable, spread out and worthless. It will be there, but it's no longer usable. Much as the water, and having traversed the waterfall and having turned the old grist mill's wheel, now lay at the bottom of the river, is no longer usable. The energy of the universe will be so spread out, and the planets are just going to spread further and further apart, and at the end of the day, it's just going to be one cold, dead, dark universe. So just how sure are we that this is our fate? Famed scientist of years back, Arthur Eddington, said, "If your theory is found to be against the second law of thermodynamics, I give you no hope. There is nothing for it but to collapse in the deepest humiliation." We may not like the implications of the first or second laws of thermodynamics, but nevertheless, they are.